my shoes and out the door.
So today we're going to be experimentally determining the KSP of lead-2 iodide
by creating stock solutions of lead-2 nitrate and potassium iodide,
and then by determining the concentration of Pb2+ and I- in a combined solution at equilibrium.
For safety goggles.
And make sure you don't eat or drink anything that you make in this lab because lead is poisonous and you generally don't want to eat or drink anything in labs.
You will need
2 graduated cylinders to measure out water and the stock solutions, 2 volumetric flasks to make stock solutions of lead-2 nitrate and potassium iodide, solid samples of lead-2 nitrate and potassium iodide, 7 100 ml beakers, and distilled water.
For 100 milliliters of a 0.02 molar solution of I-, we're weighing out 0.332 grams of solid potassium iodide. For 100 milliliters of for a 0.01 molar solution of lead-2, you'll need 0.331 grams of solid lead-2 nitrate. Did you hear that potassium and oxygen went on a date?
Oh yeah? How'd it go?
It was okay.
Take a look and see a beautiful morning that turns into a beautiful evening, and together make a beautiful.
Hey Shannon, what are you dissolving there?
Lead-2 nitrate.
Hey, you know, why do chemists like nitrate so much?
Are you starting?
Why?
Okay.
Because they're cheaper than day rates.
Using dimensional analysis, we're using the masses we actually weighed out to determine the molarity of each solution.
To find when the solution is at equilibrium, we're using varying concentrations of each stock solution with varying amounts of water. We are ultimately looking for the beaker in which the smallest possible amount of precipitate is found.
Take a look and see a beautiful morning that turns into a beautiful evening, and together make a beautiful life. And if you wanna see, then come along with me, that's right. And if you want a good tomorrow, it's pretty simple, gotta find a light to follow. And if you do, you have a future real bright. And it's a combination of consistency. Come on and sing, oh, 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 oh. Come on, come on, come on and sing.
To find where the solution really is at equilibrium, we're adding an 8th beaker between the beaker in which the solution is clear and the one in which we start to see tiny flakes. So this 8th beaker will have 26 milliliters of water and 7 milliliters of Pb2+ and I-.
We used the concentrations of lead ion and iodide ion to calculate the KSP for this solution. We compared the expected value of KSP with the actual value of KSP for the solid and found the percent error of our experiment.
53% error. I'm not happy. I want a titration. Okay, so for the titration, you're going to take one of the stock solutions and titrate it into the other one. And the one that you're titrating should be the known concentration, and you're going to titrate it into the known volume of the aldehyde light over here. And that way you can calculate the exact volume that's needed and you get a more precise value of KSP. So once you start to see the gold flakes, that's exactly how much volume you're going to need, and that will be the molar solubility, and use that to calculate KSP. Okay, so we're going to rinse the burette with the titrants to make sure there's no contamination. Okay, so now we're going to add the titrants that we're going to titrate the solution with. And we're going to record the initial volume. Okay, so now we're going to slowly titrate the solution with the Ki and mix after each time to make sure there's no precipitate. Hey, what are you doing there?
A titration.
What did one titration say to the other?
What?
Let's meet at the end point.
Face hurt and we'll laugh, jump, sing loud, not afraid to shout about being happy, living it out.
Hey Shan, did you finally work out that problem?
I'm still figuring it out.
Oh, I got the solution now.
Red wine. Let's go to the beach, let's go.